we've got a cross-section of pipe or tubing. Now you can think of water flowing out of the cylinder through a tube. If you put a longer tube on that cylinder, it's going to slow things down because water is not an ideal fluid. It adheres to the boundaries of the tube, slows it down to zero at the boundary, okay? And then what happens between the boundary and the center? Well, the further you are from the boundary, the faster the water goes. Reason being something like this, okay? So let's imagine again, we're partitioning, this time by surfaces that we think are going to be characterized by more or less equal velocities. Okay? So we got three positions here. Okay? So now remember, these represent cylinders of some length. Okay? So surface area of a cylinder, distance r from the axis, and you should be totally okay with this, is 2 pi r times L. 2 pi Earl. Okay? And growing up, we had a very colorful milkman named Earl. He could actually deliver milk. People used to do that. And take a 2 pi Earl. He'd just walk into the house and, fill the refrigerator, walk out, it's that kind of, and, if we had 2 pies in there, he would have eaten them. So there's 2 pi RL. Okay, well, that's totally 2 pi RL, right? We understand that's the circumference you multiply by the length. Okay? Yeah, on this surface here, you've got a layer that you're going to kind of assume is stationary because it's in contact with the walls of the pipe. And one here that you assume is moving at some different velocity. Okay? The pressure I don't want to talk about pressure. Cylinders slide past one another. And in the sense of here there be dragons, here there be something like friction. Okay? Proportional to the area of contact. Okay? And relative velocity. Okay? The proportionality constant is denoted eta. That's a bad eta. Been a while since I wrote. And that's called viscosity. Okay? The more viscous the fluid is, the more slowly it's going to travel through these tubes, because the more force there is between surfaces. Actually, force the area of contact, the thickness, of the shell comes into it, and we'll talk about it more, but I want you to kind of get the geometry of that and the idea in your head so we can set up some integrals. Fair enough? So think about it.